All right. So in our last video, we were looking at the linear transformation on the screen, and we found the kernel and the image. So in this video here, what we're going to do is we're going to use those descriptions to find a basis for both the image and the kernel. So let's get back to it. So the image, right, recall we found that the image was the span um, well, really what this corresponded to was the first of the columns of the standard matrix. So the span of 1, 2, 1, 3, 4, 6, 2, 6, minus 1, and minus 3, minus 10, 3. So now we're going to apply our method for finding a basis for the span of a given set of vectors, right? So in other words, um, which of these vectors are linearly independent, right? We want to find that linearly independent subset. So to find a basis, we calculate the row reduced echelon form of the matrix obtained with these vectors here. Right, notice that even though the first two vectors are obviously linearly independent, right, because one is a multiple of the other, we actually don't know that, like, there might be others. And so that's what calculating the ref is going to help us with here. So throwing this into octave, I got 1, 0, 0, typo there, 0, 1, 0, 5, minus 1, 0, and minus 9, 2, 0. So in particular, this matrix has two pivot columns, and they're corresponding to the first two um, columns. So it's actually just the first two vectors that we're going to keep. And you'll notice that even though I said the first two vectors were multiples of each other, I was incorrect. Got my eyes a little crossed there. But all the more reason to actually go ahead and do the row reduced echelon form um, to confirm your logic. So there's our basis for the image. Make a little more space there. For the kernel, right, we previously computed this guy. This was the set of vectors of this form. And if we just keep breaking up these linear combinations, right, so these are vectors of the form like so, plus b, 9, minus 2, 0, 1. And so the basis for kernel are these two vectors here. All right, so that's how we get all the way to finding a basis for the image and the kernel. And then in our next video, we'll explain how to piece this together in the rank nullity theorem.